Hello viewers, this is Mr. Banda, and in this lesson we are looking at permutations and combinations, part 2 of our tutorial video. And here we have question 5b1 and 5b2, and these questions are coming from paper 2 2023, question paper number 3 of Additional Mathematics 0606 International Cambridge. Now, the question is saying, given that n is greater than or equal to 4, we have to show that n minus 3 times n combined 3 is going to be equal to 4 times n combined 4, or you can read this as n choose 4. So we have to show that n minus 3 times n choose 3 is equal to 4 times n choose 4. And the second part of the question is saying, given that n choose 3 is equal to 5n, we have to show that n satisfies the equation n squared minus 3n minus 28 being equal to 0. Having shown that, we are supposed to find the value of n. So let's look at how this must be done. Working. Now, given that n is greater than or equal to 4, how do we show that? So that's question 5b1. So how do we show that n minus 3 times n choose 3 is the same as 4 times n choose 4? To begin with, let me explain the definition of n choose 3. So, our n choose a. So, n choose a or r, we can use n variable, means n factorial over r factorial times n minus r factorial. This is how we define this operator here, c. It is defined by this. Okay, where n factorial means n times n minus 1 times n minus 2. You go on and on times 1. Okay, that's what we have. That's the meaning of n factorial. So in this particular proof, we just have to use this definition, okay, and this one here, these two. Then we'll be able to prove that this is equal to that one. So let us see how can this be done. So in this one, what we have is n minus 3 times n choose 3 means n factorial over 3 factorial times n minus 3 factorial. Okay, so what is this going to give us? This will give us n minus 3 times n factorial over, you have 3 factorial times, what is n minus 3 factorial? N minus 3 factorial is n minus 3 times n minus 4 factorial. By definition of factorial, so from n minus 3 factorial to be n minus 3 times n minus 3 minus 1, from the definition, times n minus 3 minus 2, going on and on, which is the same as n minus 4, because n minus 3 minus 1 will give you n minus 4, then factorial. Okay? Now, having done this, you can see that n minus 3 here is common. So n minus 3 can go into n minus 3 once. So you end up having n factorial over 3 factorial n minus 4 factorial. This is equal to 4 times n combine or choose 4. Okay, this is what this is. How do you know that? Check what 4 times n choose 4 is. So you can see that 4 times n choose 4 will give you n factorial over 3 factorial times 4 times n minus 4, then factorial. How? This will be 4 times n choose 4 is n factorial over 4 factorial, then n minus 4 factorial, isn't it? So this is what we have there. But what is 4 factorial? Okay, so this will be 4 times n factorial over, what is 4 factorial? 4 factorial is 4 times 3 factorial. Because it is 4 times 3 times 2 times 1. Now 3 times 2 times 1 is 3 factorial. Okay, then in brackets we have n minus 4 factorial. So I'm taking this side. So we have 4 times n factorial over 4 times 3 factorial, then n minus 4 factorial. This 4 and this 4 can cancel out, or you can divide, you get 1, then this will give you n factorial over 3 factorial times n minus 4 factorial. You have seen that 4 times n choose 4 is giving us n factorial over 3 factorial n minus 4 factorial, and n minus 3 times n minus times n choose 3 is also giving you the same. So you can conclude that therefore n minus 3 times n choose 3 is equal to 4 times n choose 4 shown. This is just a 2 marks question where you just have to do the algebra or arithmetics of the definition of what n choose 3 and n choose 4 is. So that's how we show that these two are equal. Now coming to the second part of the question, where we are told that given that n choose 3 is equal to 5n, we have to show that n is going to satisfy this equation. Having shown that, we are also supposed to find the value of n. So let us look at B2. Let us look at B2. Question 5B2. Given that n choose, so we are saying n choose 3 is equal to 5n. How do we show that n is going to satisfy this equation? So n choose 3 being equal to 5n, we have that n choose 3 means n factorial over 3 factorial, okay, 3 factorial and n minus 3 factorial. That's what n choose 3 is defined, or it is. So it is n choose 3 is n factorial over 3 factorial, n minus 3 factorial. This is equal to 5n. Alright. What is n factorial by definition? N factorial is defined to be n times n minus 1 times n minus 2 times n minus 3. Now you go on and on to n minus 4, n minus 5, n minus, but n minus 3 times n minus 4 times n minus 5 is the same as n minus 3 factorial. Okay, so where there is that, I'll just end it on n minus 3 factorial, so that I was able to cancel it out with n minus 3 factorial, which is down here, over 3 factorial gives you 6, because this 3 factorial is 3 times 2 times 1. That's what 3 factorial is. So it will give you 6. And here you have n minus 3 factorial. Now you can see n minus 3 factorial on our numerator. We also have it on our denominator. So you can divide it. N minus 3 factorial into n minus 3 factorial, you get 1. Okay, so this is equal to 5n. Then our equation will become n times n minus 1 times n minus 2. Okay, over 3 times 2 times 1 is 6 is equal to 5n. This is what we are going to get. Having gotten this, we can expand what we have there. Or before we expand, you can see that this n is common here. So you can divide here by n, and also there you divide by n. Okay, so dividing by n here will yield 5, and dividing by n here, you will cancel this n here. Because we are multiplying there, so we are allowed to divide. So this n and this n will cancel out, and this n and this n will cancel out. In short, this n can divide that n so that you don't have that. So what we are going to have here is n minus 1 times n minus 2 over 6 is equal to 5. So this will be cross multiplying here. It will give us n minus 1, then n minus 2, giving us 30, because 6 times 5 is 30. 1 times n minus 1, n minus 2 will give you this. Let us expand this. N times n, you have n squared. N times negative 2, you have negative 2n. Negative 1 times n, you have negative n. Negative 1 times negative 2, you get positive 2, being equal to 30. Then you have n squared minus 3n, because negative 2n plus negative n, you get negative 3n. Then plus 2 minus 30 is equal to 0. Okay, so this will be n squared minus 3n plus, so what is positive 2 minus 30? You get negative 28 is equal to 0. So you have shown, we have shown that n is going to satisfy this particular equation, which we have brought it up there. That's the equation that we have. So we have shown that indeed when you have this, n is going to satisfy that. Now how do we solve for n? So now how do we solve for n? We just have to solve this particular quadratic equation for n. So let us solve. We have n squared minus 3n minus 28 giving us 0. So how do we solve for n? In this case, we have our product is negative 28 and our sum is negative 3. The factors will be negative 7 and 4. These are the factors that will satisfy these two conditions, where the product is negative 28 and the sum is negative 3. Now, let us factorize. You have n squared minus, so minus 7n plus 4n minus 28 is 0. N is common, you have n minus 7. Positive 4 is common, you have n minus 7 is equal to 0. Then you have n plus 4 or n minus 7 is equal to 0. Now, take note here that you are told that in this case, for combinations, n can never be negative, okay? The number of items can never be negative. So, we'll have n plus 4 giving you 0, or n minus 7 giving you 0. But this one will yield n being negative 4, which is not applicable. So, this is not part of our solution. Therefore, you have n minus 7 being 0, implying that n must be 7. So you conclude n is equal to 7. That's the value of n. So this is what we are supposed to do when we encounter questions to do with permutations and combinations. I hope and believe that you learned and enjoyed the lesson. God bless you all, and do not forget to subscribe to my YouTube channel, Mathematics Made Easy with Mr. Banda Moses. God bless you all once more.